Hello everyone. In this video, my objective is to show how to graph a polynomial function. Now I'm using Desmos graphing calculator, and here is the example that I was able to acquire on Pinterest. But anyway, this is what we are going to graph using Desmos. So function f of x. Now remember, f of x is nothing but your equation y equals or a function of x. Okay, so here you have x plus 3 the whole square times x minus 1 the whole square times x minus 5. Now you can see that this function has certain features, and prior to this you should have checked out the other videos where we have talked about what a polynomial is, how to identify the degree, how many terms are there, what are x-intercepts, and then and what's the domain. Now I was not able to provide domain. Domain is nothing but your x-axis. Okay, so the values of x, and range is the values of your y. Now here what you notice is for this function we are going to identify the degree. So one way is doing expansion and then finding out highest power. But we know by the rules of index laws or exponent rules, when you have terms like this, like terms are getting multiplied, you can add their powers. So 2 plus 2, and here it's invisible 1 there. You should know that the power is 1. So 2 plus 2 plus 1, that should be 5. So the degree of this polynomial here is 5. Then what are your x-intercepts? X-intercepts are nothing but, in other words, zeros. It's the point where your y value or the function f of x becomes 0. So if you look here at negative 3 comma 0, the function is becoming 0. The y value is 0. 1 comma 0, that's another x-intercept. Basically the function touches the x-axis, and any point that is on x-axis, the y have to be 0. The point of contact is called x-intercept. So that's what we are checking out. So the other final one is 5 comma 0. So it has 3 intercepts or 3 zeros. Now where does it bounce? It bounces at 2 values. So one is at negative 3 and the other one is a positive 1. At x minus 5 is it's acting as a linear function, but the other two, it should look like these quadratic functions, and then it stays constant. So it's only changing at 2 values of x where the function is bouncing, which is nothing but your negative 3 and positive 1, those 2 values which are derived from this particular piece or this particular term. Now domain is nothing but the extent of your x value. So as you can see, these arrows indicate that the graph is going to go to the negative infinity, and this is going towards the positive infinity. That's why we call the domain as a function that is included the values from negative infinity to positive infinity. Now the end behavior is positive. Now the other thing we all need to agree is polynomials cannot have negative powers, negative exponents. Powers are nothing but exponents or indices. In different math textbooks you'll find the word interchangeable, but this is how you would have graphed and verified your polynomial function. But again, please make sure that prior to you watch this video, there are other videos where there are definitions and simple ways to check your understanding on identifying the degree, number of terms, and how do you name a polynomial based on the highest degree. All this in the other videos, but this is just on the graph, a quick check of understanding that you should develop regarding polynomials and how to sketch them. All right guys, thanks for watching and have a blessed day.